Hey everybody, how are you doing? Hope you're having a good Tuesday. This set of notes that were attached to the lesson plan today are a very thorough explanation of the A, B, AB, and O blood types, and also the RH, which is rhesus factor, RH negative and positive blood types. Okay? I'd like you to go through and read this on your own. It talks about Karl Landsteiner, who actually won the Nobel Prize for figuring out human blood types. He also figured out the RH factor in his work with rhesus monkeys. Humans also have, or don't have, this factor. Okay. This table shows you all the possible alleles a person could have. And you see the I for immunoglobulin? And the A, that's for the antigen A. This second parent is also A. That means their offspring will end up homozygous A and have a phenotype, the blood type, A. It works the same way all the way down. If one parent donates an A, the other parent donates B, their offspring will be AB. Okay? Here is the only way to get type O blood. One parent has to donate a recessive O. The second one also has to donate a recessive O. Then they have the homozygous recessive genotype and the recessive phenotype type O blood. This is more information. Okay, here's something you might find interesting. This is just different people's ethnicities and cultural backgrounds, where they end up on the scale as far as what blood type they're most likely to have. This blank explains RH factor. Okay, so let's start with sample 1. We have a patient rush to the ER, and this person has severe blood loss. They're type AB positive. The hospital doesn't have enough type AB positive, but a nurse says, oh, it's okay. We can give him any kind of blood. Why is that true? Okay, this is why. Don't look at RH yet. This person's genotype is AB. The phenotype, AB. They are RH positive. Okay? So this person can take blood from type A transfusions, B transfusions, AB transfusions. They can take type O blood, the universal donor. They're RH positive, so they can accept RH positive or negative blood. Now, if this person was not RH positive but was RH negative, they would not be able to take any kind of positive blood. They could do A negative, B negative, AB negative, or O negative, but no positives. Okay. Let's talk about sample 2. Here's your man with type B blood. Let's make him homozygous B to start with. And here's our woman with type AB. Could they have a type O child? Let's find out. Okay, this particular 25% probability of their offspring is AB. This one is the same. This one is homozygous B. And this one is homozygous B. So in this, if he is homozygous B, there's no chance. What if he is heterozygous B? In other words, he has one B allele and one recessive O allele. The woman is still AB. I bet you can already tell there is no way for her to ever produce a child that is type O. She would have to have an O allele to donate to her offspring. She doesn't. Her children are either going to be AB, heterozygous A, heterozygous B, or homozygous B. So the answer, no, and you proved it with your work. Sample 3. If the mother of a child is blood type O, so here she is. She's homozygous recessive type O. That's her genotype. And the child is blood type A. Okay, well, we've got 2 possibilities here, so we may have to check it both ways. They could be heterozygous A or homozygous A. What types could the father be? Well, let's work backwards. We have a child who is blood type A, right? And we know that the mother is O. So let's fill her in. She is not giving anything except for the recessive allele. Okay? Now, the child ends up as an A. So we know the dad is going to be donating A's. So he could be, this is possible. He could be homozygous A, and 100% of their offspring would be heterozygous A as their genotype with A phenotypes. He could be heterozygous A, and this 50% of the children would still end up with type A blood. What if he was type AB? See, it still works, because in that case, we still have 50%. So basically, as long as he is donating an A, he could have 3 different kinds of blood. He could be, so here's Dad. He could be type AB or homozygous A or heterozygous A. But he can't be type O because the mother cannot donate an A allele to give this child type A blood. Okay, practice 1. A medic is treating a wounded soldier who has lost a great deal of blood in combat. The medic, who happens to have type O blood, is out of blood typing supplies. Consequently, he decides to donate his own blood to the wounded soldier. Why could this work? In other words, why is type O blood called the universal donor? This situation is possible, but only if that medic is O negative. If he has a positive RH factor, he could actually kill this soldier. Of course, the soldier is going to die anyway, so it's better to take a chance, I suppose. So in this case, let's see. If he is O negative, it won't matter. This wounded soldier could be type A, type B, type O, and hopefully he's also positive RH. And we already talked about what if the medic is positive RH. Practice number 2. A practical joker snuck into a maternity ward and removed all baby ID bracelets. There are 3 babies in the maternity ward. One has type AB blood, another has type A blood, the third has type O blood. A particular mother is homozygous for blood type A. So let's write her genotype. Here she is. And there. Okay. The father has type O blood. And I bet y'all are already seeing, without doing the Punnett square, that they can only have a baby with one type of blood. Which baby must belong to these parents, and explain how you know this. So, Dad's up here, genotype O. Mom's here, genotype homozygous A. What do every single one of their offspring have as far as a blood type? That's right, they are all heterozygous A's. So all their babies will always have type A blood. Practice 3. The police have 4 suspects in a rash of textbook thefts. The suspects have the following blood types: O, A, B, and AB. At the scene of the most recent theft, the thief got a nasty paper cut, and the blood was found to contain I alleles, so O alleles. Which suspect should immediately be released based upon this information, and how do you make this determination? So, we've got four usual suspects, right? We have the O, which is homozygous recessive. We have the A, which could be homozygous A or heterozygous A. We have the B, that can be homozygous B or heterozygous B. And we have our type AB, who can only be codominant AB. Okay, so the question is that this particular blood sample from this horrible paper cut was found to have the recessive O alleles. Which suspect should we release right away? Well, which one of these four is there absolutely no chance at all of them having any O alleles? The AB. So they get to go home, but everybody else is sticking around. Okay, well, I hope this helped y'all. Your homework is questions 1 through 10. I do want you to create Punnett squares for numbers 3 through 6 and numbers 7 through 9. You may find you need to do them for 1, 2, and 10 also. It's great practice. There will be blood typing problems on the test. And if you want my help, just email me and we will set up a time to FaceTime, or we can talk on the phone, or maybe I can just help you with email. Okay, y'all have a great evening or day. Okay, talk to you later. Bye.